I'm seeing quite a few familiar names from other people who've been to some of our other webinars in this series. I see, for example, Dominique and Dan Jenkins, and Frederick as well. Just some of the names that are coming up. I actually see my cousin in there too. So welcome, cousin. I won't out you just yet. And some familiar names from both the US and from South Africa. So welcome to everyone. We're just going to give it a minute or two while we just allow people to come in. At the moment, you can see a picture of myself and Micah. So just while I'm mumbling along in this part, just to explain to you this webinar is part of an IEA webinar series on the future of work and the challenges that this poses for human factors and ergonomics. And in this webinar series, we've done quite a few things, including gone around and heard from different people around the world about the different types of challenges for the future of work in different parts of the world. And this webinar and the last webinar have been about a topic which is of global interest at the moment, and that's about artificial intelligence and robotic teaming. The speaker that we have today is Micah Endersley. Let me use this opportunity so as not to use up more of her talking time, and for you as the audience, the question and answer time. So let me just very briefly, because it's going to have to be very briefly, introduce you to Micah Endersley. So Micah is currently president of SA Technologies. SA in this context stands for Situation Awareness, and formerly she was a chief scientist for the US Air Force. She's had various visiting positions at a number of esteemed institutions, including MIT and Texas Tech. She is both a fellow and a past president of the Human Factors and Ergonomics Society in the United States. She's a recognized world leader in design, development, and evaluations of systems to support human situation awareness, of which many would consider Micah to be the grandmother. That's perhaps giving a little bit of age away on here, but not that we intend to do that, of situation awareness, in particular situation awareness in highly complex integrated human automated systems. She's authored over 200 scientific articles and co-authored a number of books, including books on situation awareness. And most recently, she was involved with producing a publication for the NSF on human AI robotic teaming. So without any further ado, Micah, I'm going to hand over to you and your presentation. Just before I do that, if you have any questions, please feel free to use the Q&A function. What we'll do is I'll monitor those channels, and at the end, we'll have some time for some questions from the audience. Micah, over to you.
Thank you so much, Andrew. And I'm happy to be talking to you all today on AI. Let me share my slides here. There we are. All right. So I'm going to be talking today about the whole issue of how we work with artificial intelligence, and in particular, looking at the lessons learned from about 40 years worth of research on how people interact with automation and AI systems that I think provides a lot of important input into this whole question of how do we create guardrails for the use of AI. AI has been developing for quite some time. Most histories track it back to about the 50s, when we saw the serious increase in actual research on AI, beginning with the Dartmouth Summer Research Project in the mid-50s. We saw a huge flow of, boy, AI was just going to be right around the corner through the 80s and 90s, most of that work where it was in rule-based systems. I have been around long enough that I actually was designing systems in Lisp back in that time period in Prolong, for those of you who go back that far. But we also saw things like case-based reasoning approaches, Bayesian networks. When we figured out that expert systems weren't quite going to work out with rule-based systems, then it's proceeded into learning algorithm approaches from everything from original genetic algorithms to neural networks to now we call it deep learning type models. In general, what's happened is as the field has learned that, oh, it's not going to be quite as easy as they thought it was going to be, we also saw significant increases in things like computational power, the rise of big data, which created large data sets that you could use for training these algorithms, and much better understanding of how learning algorithms needed to work. So we've seen a significant increase in trying to create AI. Now, AI, I think, is actually a bit of a misnomer. We're not even sure what real intelligence is, much less artificial intelligence, but they have defined it as a system that can recognize situations, adapt to change, and generate solutions to even novel problems, and can act to optimize performance. I would say that today's AI systems are still quite a ways away from those types of capabilities, even though it does act in ways that we might consider more intelligent than simple programmed automation. The AI is being applied in a wide variety of domain areas, everything from e-commerce that's recommending books and movies that you might like to watch, or things you might want to buy on the internet, to systems that are now going to increase our access to information through tools such as ChatGPT. And then we're seeing in a lot of work-based applications, driving, healthcare, robotics, finance, aviation, military systems, policing, and manufacturing. So really across the board applications where people are saying, hey, AI is going to solve your problems here. It's going to do things that people aren't very good at or don't do enough of. And so it's following the same pattern as previous waves of automation, where it is telling us that basically these systems are going to be better than people. There's a lot of challenges, of course, to that claim, which often isn't really backed up very well. But first, I think, is the whole problem that AI may not be accurate. And when we look at applications that we're seeing, certainly on the internet, we have problems with the fact that they could be providing absolutely false information. So these deep fakes are quite difficult to detect. Everything from images which aren't real, videos that are not real. And they're quite believable. I have watched videos of one person talking and the words coming out of another person's mouth and that person's own voice that look absolutely compelling and believable. This, of course, is creating significant challenges for deceptive activities that are going on, whether it's people who want to take money from people by fraudulently making fraudulent claims, to deception in the political arena that people are grappling with today. We also have the challenge that even if the AI isn't being used in deceptive ways, it could still be deceptive in that ChatGPT, for example, creates hallucinations. And that is, the program really is a natural language program. It does a very good job of creating language that looks very realistic and natural, but the content behind it could be completely inaccurate. And they call these hallucinations. I have, for instance, asked ChatGPT who I am, and it has created completely fictitious universities I went to and completely fictitious jobs I never had. No idea where that information comes from. Nobody knows where it comes from. And that, of course, is one of the problems, is you really cannot decipher what's real and what's not from what's coming out of these types of systems. More to the point of where we're going with a lot of job applications is that it simply is not necessarily reliable, in that it is not going to be competent to do all things. And in particular, it may not be, well, it can handle situations it's been trained on. The learning models are essentially pattern matching algorithms. They learn patterns and are therefore predictive of what's the high probability of what something is or what something's going to happen. It is not really able to handle novelty particularly well because of a number of reasons. One of these, of course, is that these AI systems still have many perceptual limitations, and there are a lot of examples on the research base that you can look at where their ability to detect basic objects becomes easily disrupted in noisy environments. So, for instance, you can take a stop sign, you can place a few pieces of tape on it, and it will misrecognize that stop sign as a yield sign or something else. The ability of these systems to just get good visual data, particularly in the real world, is very troubling. It still has a lot of challenges in recognizing things that people wouldn't have any trouble with. And it could still be getting bad data. So, for instance, if it's getting bad sensor data, it's going to give you bad outputs. Brittleness, of course, is another problem that's historic with automation, and that is that it still only covers situations that are covered by its training. While learning systems could, in theory, learn new classes of situations, and that is something that either tends to happen offline or at least with a learning lag. So it's still going to be inaccurate when it encounters these novel situations. And the challenge, of course, is that it may not recognize it's novel. It doesn't know the limits of its own programming to know what things it can do and can't do and when it needs to call for help. Hidden biases are a problem, and I'm going to talk more about this in detail. But these biases arise from the fact that it only learns what's in training data. So there can be biases built into that training data. We've seen a lot of historical problems with, for instance, job application systems that will weed out people if they don't meet the generalizations that it has in its training set. So we have seen a lot of examples where the system was trained, for example, that men were more likely to be successful job applicants, therefore it just weeds out the women. And you have a built-in bias that occurs in that way. Those biases, though, are not intentional prejudice, but limitations of the training set that has been provided to it that the developers may not have even understood was in there or what the implications are going to be. And more importantly, and lastly, I think that even if we are able to address some of these earlier issues, a fundamental challenge with learning-based AI is that it has no model of causation. And there's some really good work by Pearl and McKinsey. It's called the Book of Why, which I would recommend to people who are interested in this topic. But it talks about the importance of having a causal model. People's human intelligence is actually driven by having causal models that help us to understand and predict what's going to happen in the world. And they argue that without those kinds of models, it can't predict future events. It can't simulate the effects of potential actions, and it can't reflect on past actions as to why something worked or didn't work. And it can't learn when you should generalize to a new situation and when you should not. And those are really fundamental problems with the approach, this machine learning-based approach to AI. That creates these black boxes that don't really have these kinds of causal models in it. And so this field of computer science is really arguing that to get to truly intelligent systems, we're going to need to bypass this current fixation on machine learning models and actually move probably towards more hybrid models that do combinations of pattern matching based AI as well as causal model based AI. And that may necessitate a whole new fourth wave of AI systems really to get to there. So these are some of the real challenges we have that I think prevent this current instantiation of AI from being truly intelligent in the way that we have been hoping AI might be. Now, the challenges we have, of course, when we talk about this from our perspective is, given these limitations of AI, what does this mean for us? And I think AI is really, it's just an advanced form of automation. And all the research that we've done on automation and AI over the past 40 years applies equally well to looking at what are the implications of people who are going to be working with AI in these various application fields where it's taking hold. And these challenges are well known. And these will be familiar to many of you, but things like automation confusion. People who are working with these systems are often confused about what it's doing, why is it doing it, what's it going to do next, the famous words of Earl Wiener. And this is because we have very poor mental models of how the system works, This is challenging enough with automation. It's really challenging with machine learning based AI because it's a black box. There really is no rules about how it's going to interact. It has created these internal patterns which are not easily exposed, and people don't really have good understanding of what they can do. We know that working with AI and automation can not just decrease workload as people assume, but it actually can increase your cognitive workload in trying to understand what it's going to do. Problems of decision biasing are significant, where if it's incorrect, it will bias us towards also making incorrect decisions. We have a history of seeing reductions in manual skills as automation does more tasks. We've seen this in driving. We've seen this in flying. We've now seeing it in driving. We're seeing it in other kinds of tasks. And then the challenge of out of the loop performance, where people who are supposed to be monitoring, overseeing automated systems, of course, are very slow to do so. They have real challenges in understanding what's happening with the situation. They can become disengaged and be engaged in other kinds of tasks. And they have problems in recognizing that this is a situation I need to take a hold of, or understanding what really I should be doing in this situation, because they have to regain situation awareness. So that gap in reacting to problem situations and being able to intervene is a significant issue. It's one I've done a lot of work on myself. And we find that it's not just a matter of people not being vigilant or not paying attention. Although the technology itself actually has very negative effects on your attention. A lot of times it's that there's very poor information about the systems that people would actually need to understand what's really happening with the system. They have not been very transparent. And fundamentally, we find that when you are passively watching these systems, you are not as engaged as when you're actively doing things. And that has a significant effect on your situation awareness. And of course, all of these problems lead to an increase in catastrophic failures. So the use of AI and automation in many systems can reduce a lot of the small errors that people might make, but you can get an increase in these catastrophic failures. And Chris Wickens has called this the lumberjack effect, where when you fall big. So what does this mean for how we want to work with AI? There are a number of concerns that people are having about these systems. Some of the long-term concerns have to do with employment impact. How is this going to affect jobs, both small and large? We're seeing that AI can have probably more of an impact on knowledge-based work, whereas previous versions of automation have largely affected skill-based work. And that, of course, has people alarmed. Currently in the United States, Hollywood is facing a strike among writers and actors because, and one of the key issues there is that these generative AI systems, they're being used to take over their jobs. They can use generative AI to develop scripts. They can use generative AI to place words in the mouths of actors that they haven't spoken. So that's having already a job impact for them. Loss of skills, of course, is a potential problem as we have automated driving take over. Will we have a loss of manual skills for driving? Will taxi drivers lose their jobs? Those are some legitimate concerns. One I'm not so worried about is this singularity, where AI is going to become sentient and take over the world, because it's going to be so much smarter than us. I am a lot less concerned about that, both because I think AI is a very long way away from becoming that intelligent. And I think that if we ever get that far, we will have done a really bad job of putting good guardrails on. What I am concerned about, and what I'm going to talk about today, is really more immediate concerns. And that is people are going to be working with AI in these jobs. I don't think it's going to be taking over people's jobs. What we really see is it infiltrating their jobs. We see AI coming into healthcare systems where they are supporting the diagnosis of people who are reading x-rays, for example. We're seeing AI take over parts of the driving job, but not all of the driving job. We're seeing AI being used, for example, by software programmers today, where AI is generating parts of the code per their direction, which they're overseeing and interacting with. And I think this is a much more common way in which automation has historically come into play in jobs, and where how we're going to see AI coming into play, where people are going to be interacting with it to do the kinds of things they need to do. So if we think about these kinds of effects on human performance that we've talked about, then what we really have to do is to figure out, I don't think we can stop the tide of AI. There's too much financial motivation for companies who are generating these AI systems. I think it's here and it's going to continue to be here. But what we really have to do is to work out ways to make that AI useful and productive, but also guard against some of these negative effects. And that's the balance that I'm trying to take in looking at how to solve some of these kinds of issues. I think there's widespread agreement that AI needs to be developed and used in a way that's responsible, ethical, and safe. You see a lot of AI policy statements. The EU has one, the United States have some, that they're coming around worldwide, and they say things like this. And certainly have full agreement with that. I think the challenge is that the devil's in the details in specifying, well, what does it mean to be responsible, ethical, and safe? And how do we implement very specific guidelines and guardrails to make sure that it is responsible, ethical, and safe? And this is where I think the human factors and ergonomics profession is very well poised to make some very useful and specific kinds of inputs into that discussion. We have been researching this topic for at least 40 years. We know a lot about what works and what doesn't work, and where the details are in creating systems that people can work with effectively. And so that's really what I want to talk about in this discussion, is what that research base can tell us about creating these guardrails. So I'm looking at this from the standpoint of how do we collaborate effectively with AI in our jobs. And I think that if we think about the human and AI as a team that has to collaborate and do tasks jointly, that's probably a useful framework. And that's because people are either going to have to be overseeing what the system is doing, they're going to have to intervene when it is needed. And when AI becomes more and more capable, they're going to have to coordinate and collaborate on different functions as we trade off and say, I want you to do this now and do this later. You can get a dynamic trade-off of those kinds of tasks. And that's very much consistent with how we see people acting with automation in many different kinds of jobs. So what are some of these guardrails then that we're going to recommend to facilitate that type of interaction? The first is we really have to better understand the veracity of the AI system. We know that, first off, people are very easily fooled into accepting information that confirms their existing beliefs. This is classic confirmation bias that comes from some of the seminal work of Kahneman and Tversky, where if I have a pre-existing set of beliefs in terms of what's happening or what's real, if that fake video I'm seeing confirms that, I'm going to be very likely to easily believe that information. This already exists with fake news. It's going to be even more compelling when we see video or pictures that confirm our pre-existing beliefs, whatever those are. It's also a problem with AI systems in other types of applications where if I have the wrong mental model of what's happening, if it confirms that mental model in some way, then I'm going to be much more likely to believe that information. Secondly, people really aren't aware of how that AI, what limitations it has in many of these kinds of systems. They think it may be able to do much more. I think a lot of this is the term AI itself. The movie culture has encouraged us to think of these AI systems as being smarter than us and more capable than us and more rational than us. And in fact, they have very significant limitations of their own. And then most people really aren't aware how it could be negatively affecting their own performance. So we have, I think, a need to look at guidelines that specifically address some of these kinds of challenges. And so the first guideline is that AI should have very explicit labeling. And that is, I think anytime you're getting the output of some sort of generational program, for example, it needs to be specified that this comes from a computational system. If it's coming from a recommender system, or whether it's a generational AI, or if it's in your cockpit, you need to know what system is actually producing that kind of recommendation. And further, you really need to know what the source and provenance of the underlying information is. So if the Chat GPT writes you an article, right now you can't tell where any of that information came from. You don't know whether it's coming from a good source or a bad source. Research has shown that when asked about 100 different topics that that have known misinformation out there, in 80% of the cases, the Chat GPT would provide the misinformation and not the correct information. And it's very hard to know that without even knowing what sources this comes from. Source and provenance of information is very key feature that people use for determining how much to trust different information. And that right now is hidden in a lot of these kinds of AI systems. So explicit labeling, I think, is very important. We need to not necessarily use the word intelligent, because it's not very intelligent. Secondly, AI shall not lie. And that's a hard one to think about. But when a AI system is being used to deliberately create non-factual information, it needs to be labeled specifically as fiction. And if it is used in ways that don't use that labeling, then I think that could be treated as fraud from a legal standpoint. So what I'm trying to say here is, for example, it's perfectly okay for me to create a painting that's in the style of Picasso. There's nothing wrong with that. But if I label it as it's an original Picasso and I try to pretend it's a real Picasso, then I have created fraud. And I think the same sort of policy applies here. We can see generative AI used to create fictional products that could be used in fiction. I've seen movies, for example, where historical figures are speaking words that I know they didn't speak. That's not being used to create fraud on people. That's being used in a fictional context. That's fine. But if I use a system like that to create people saying things they did not say, and use that in a way that is misrepresented, then that is, of course, fraudulent. So we need ways of treating that, and we need to make the reliability of AI information much more transparent. So something like Chat GPT, for example, that is mixing up information that's both reliable and unreliable is very difficult for people to deal with. We need to be much more specific how accurate or how confident information is that's being provided by these systems. Secondly, we need to work on avoiding and exposing AI bias. So people are, of course, subject to a number of decision biases. This whole problem of anchoring on early information and then searching out confirmation, information that confirms it, for example, are well-known biases. And that, of course, is a challenge with AI systems. But we also are subject to things like availability bias, framing, loss aversion, etc. AI biases we've talked about a little bit. These come from the fact that these data sets are limited. So there's some selection bias that goes into selecting what training sets systems get trained on. If a vehicle is only trained to operate in Phoenix, Arizona on straight streets that are wide and don't have a lot of foliage, it may not be a good system for operating on in another city that has a lot of hills and curves and snow and ice to deal with, for example. So the limitations that are in the training set become a bias, if you will, in terms of the generalizability of the AI system that relies on that. So I like to think of bias as really an overgeneralization of any use of an AI system outside of what it's been trained to do. This, of course, creates challenges, both because people may not understand what the biases are in the system. They can be hidden from users who could be very different from the developers, for example, and also because there can be concept drift. So that is where essentially the world changes over time from what those earlier expectations were. And there may not be as good a fit even as people might have originally intended. My concern when we look at this, of course, is the interaction between these biases. And that is, given that AI may not be accurate because of these biases, we have the challenge that human decisions get influenced by AI. And that is, the AI and the human are not operating in parallel. They're not serial processors, but they actually operate in tandem. So the human, what people do is they look at the AI, they anchor on that, its input, and then we search for confirming information to say, is that correct or not correct? So the biases interact with each other, and those effects can be very subtle and below consciousness. And so what we have found in a number of studies is that if the AI was correct, then human decision-making can be good. But if the AI was incorrect, they are much more likely to make the mistake than if the human had not had that incorrect input to begin with. So that, I think, becomes the real challenge here as we look at these sorts of biases. So our guidelines here in the bias area are that we have to make the limits of the AI training very overt, particularly when that training has occurred on small data sets that have these hidden biases in them. And the developers of AI systems are going to have to be much more careful about finding out where those limits are in those data sets, and how far the generalizations made out of it can really extend. So we really have to figure out where those limitations are when AI systems are created, and we have to make those limitations very overt, because the people who are using the system are not the same people as the ones who developed the system. Secondly, we need to try to expose those biases. I would dare say that the people who developed the selection systems, job selection systems, had no idea they were perpetuating gender biases or racial biases necessarily. And there is some good computational work going on to try and make much more overt what these kinds of biases are. And then we need to develop preventative detection measures for these human and AI biases that can occur, and what those interactions are. So developing systems that will allow us to prevent those sorts of biases from rolling into real-world applications, I think, becomes a very important part of the training, of the testing process. And then lastly, I think we need to be conscious of the fact that the AI biases can interact with human biases, and try and minimize that decision biasing by improving the transparency of the AI system in terms of why it's doing what it's doing and what its inherent bases for those recommendations are. So, and that's something I'm going to talk about a little bit more here going forward. The third thing we need to really look at is supporting human situation awareness and trust. And so we know situation awareness is really critical for decision making. That's necessary to understand the state of the world, to understand others in the world. It's necessary for overseeing AI. Is it performing correctly? Is it missing anything? And then but we do know that AI can reduce human situation awareness. So this is the whole out of the loop problem. And we have a lot of challenges in understanding what AI is doing, what it's capable of doing, what will it do. These are incredibly hard with machine learning systems, where that information is not overt. It's in this black box, and it's very opaque. And this all relates to this whole issue of when should we trust the AI? People think of trust as a holistic thing. I either trust it or I don't trust it. But we find is that it's not just a generic trust issue, but trust is very contextual and dynamic. So I may trust my spouse with math problems, for example, but not spelling, or vice versa. We trust people differently based on their capabilities to do different kinds of things. And that's really what we're talking about when we're talking about AI. It's not so much just trust. Trust as in, do I expect it to be deceptive? But trust is in, what do I think its capabilities are? And do I think it's capable and able to act in the current situation in an appropriate manner? And that kind of situational trust, I think, is very important, but it requires situation awareness of what the AI is doing and also situation awareness of what the current situation is. So in this respect, then we see that we need, in order to support trust and situational awareness, we need to improve both the explainability of the AI system, the transparency of the AI system, and then we also need to pay careful attention to human AI interaction. So let me detail those in further amount here. So the whole issue of AI explainability has been getting a lot of attention over the last few years. Explainability is just looking at, why did the AI do something or recommend something? And this is very important for developing a mental model of how the AI works. What that research has shown is that those sorts of explanations should be contextual. Why did it do A and not B? And situational. People want to know, how will it perform in different kinds of circumstances and different kinds of gradations of those circumstances. So it's a very detailed kind of explanation that people are looking for. A lot of the work on AI explainability has not necessarily done this. It's done things like heat maps to say, well, these are the features it looked at, and you may have to look at hundreds of those to try and generate your own mental model of, maybe it's doing this and maybe not that. And some of the research in AI explainability has shown that that's really problematic. People can develop very incorrect mental models of what it's doing from that kind of explanation. So you need explanations that are actually tuned to the real needs of the users, and what people who work with systems need may be very different than what might be useful for the programmers of those systems. So there's you know, in going through some of these other kinds of limitations, the biggest challenge, of course, is that AI can be brittle, and its logic is not easy to explain. So there really isn't inherent logic in a pattern matching system. It's not one where it has these underlying rules and explanations within them. I did some work with one of my students many years ago where we actually created rules out of a neural network system. And you know, that was useful, it was helpful, but it probably is a generalization. It probably doesn't fully explain every nuance of how that internal system was working. And I think some of the other sorts of challenges of explanatory systems are that they are largely backward looking. So they are looking at, well, why did it do a past decision or a past action? And that's useful if I have time to sit down and look at it and think about it and interact with it. But in many of the kinds of situations we're talking about, they're very dynamic. Driving, flying, they're very active, dynamic situations. I don't necessarily have the time to sit there and query an AI system as to, well, why are you recommending that I turn left? I don't have time for that. It would use up those mental resources, and it would use up my attention that needs to be directed at the road. So that sort of an explainability system, I think, will work in some contexts, but may be very difficult in other types of time-demanding kinds of contexts. Nonetheless, it is something that we can utilize. So let's see. So our recommendations here are essentially to provide AI explanations. They can be very useful in training situations where people are trying to develop an understanding of what the system does, in simulations, and on demand, and in situations where people have the time to be able to deal with those kinds of more detailed explanations. And most importantly, those explanations really have to be tailored to user needs and to situation specifics. So a lot more needs to be done in that direction. What I do think we can do, though, that is a little different than explainability is the idea of AI transparency. And I don't think AI transparency has gotten enough emphasis, quite frankly. So while explainability is looking at the past, To me, transparency is looking at what it's currently doing and what it's going to be doing. And that is a real, I think, much more important in a lot of these real-time dynamic situations. So in terms of transparency, people want to know, what does it know? You know, what kind of data and information is it aware of? Is it getting good data? What's its current state? Is it performing properly? And what's it going to be doing, you know, in the near future? So I know, is it going to go straight on this road, or is it going to get off at the off ramp if I'm driving a automated vehicle, for example? Because what transparency has to do is it has to support real-time decision making. And we think that this is very important. There's been quite a bit of research actually looking at this transparency issue, and it's been found to be highly effective for improving situation awareness, for trust, and actually for reducing or even eliminating the out-of-loop performance problem. And there have been at least 2 meta-analyses now that have shown these kinds of far-reaching effects. So I think a lot more emphasis needs to be placed there, and it could be that the entire out-of-loop problem has been a problem of poorly designed automation that has not kept people sufficiently aware of what's going on. Some more recent work, I've published a recent paper really trying to dig more into this issue of AI transparency, looking at really what it is we need to be made transparent and how you make that transparent. But dealing with things like its state, if it has an operating mode, its current assessment of the situation, what is its reliability in the current context? How much confidence does it have in an assessment? Or how able is it to behave in the current kind of situation that it's in? So with current and upcoming situations. And I draw a couple of examples from driving an automated vehicle. For example, if I'm coming up to a lane merge and it can't handle lane merges, that needs to be made very clear and salient on the display, as opposed to me finding out the hard way that oh, it's very erratic in this kind of circumstance. And then, of course, understanding what its projected actions are and what its current goals are as we move into more complex functionality. So the recommendations here, guidelines for AI transparency is we need to make sure that these systems are made transparent to provide this kind of critical information. We know that it is critical for supporting human SA and trust. And we need to do more, I think, to develop efficient methods for conveying AI and transparency in ways that are tailored to the context, demands, and tasks that people are ongoing. So this, I think, is a big area where our profession can provide a lot of utility in this problem set. Next, I think we need to be supportive of effective human AI interaction. And that is, we know that the way in which people and AI are combined affects joint performance. This has to do with how much control and responsibility are provided to the AI. And basically, we have an AI automation conundrum where the more control, the more of a task and the more reliable it is, actually the worse the out-of-loop performance is. This gets combined with temporal transfers of control, the granularity of the control, which is how much effort has to be applied to it, and then the authority, what's really the combined authority between people and AI systems. And so we need to look here at improved methods for interacting with AI. We have to provide support for collaboration on these shared functions. We have to realize that people could be managing multiple AIs, each of which has different capabilities and could be interacting at different levels of automation. And most importantly, we have to support these transitions between people and AI system, and support the ability of people to recover SA in these abnormal situations and to predict emergent behaviors. So all of the kinds of decisions that are made about how much of a task is done, when it's done, and what level of automation that AI is interacting at, those all will affect performance. So those are very active decisions that get made in this process. I'm sort of running short on time here, so I want to finish up and allow time for questions. But I will say that going forward, people are also looking at how we actually team with AI in ways that are much more interactive than they have been in the past. There are some advantages to thinking of humans and AI as a team. but they need to have much better support for coordination and collaboration in order to get to any kind of team-like behavior. I would say that currently there is very little in the way of an example of an AI system that actually interacts effectively as a teammate that does these types of behaviors. So a lot of work's ongoing right now to try and better define what the teamwork-like behaviors are that we expect to see out of AI systems, and how we would actually build those to provide more team-like skills on behalf of what they do. If they're successful in doing that, then I think we could probably get a lot more out of these systems for a lot of kinds of applications. So we need better joint training for people working with AI in simulation environments, just so people actually understand what can it do, what should I be doing, and how we interact effectively with it. We need to do a lot better at incorporating human interaction into AI development testing. Right now, most AI testing, again, occurs just by its developers, and it's really looking at accuracy issues. But the ultimate success of AI is going to rest on its ability to work effectively with people in the system. And that has to be supported as a key part of the system development testing process. So we really need to look at joint human AI testing, both before it gets released and actually as an ongoing part of its life cycle, because of these issues I've talked about with machine learning changing its behavior, changing its capabilities. It's going to have to be an ongoing process of testing and training as the system evolves and develops. So incorporating human AI lifecycle development testing, I think, should be a key requirement. And lastly, we need to make AI safe in these safety critical domains we've talked about. And these are, I think, things we have done as a profession for many, many years, dealing with safety alerts that are salient and timely, making sure the system fails safe, and doing validation and certification. Anytime we're going into a safety critical application like driving or flying or military applications or healthcare, we have to do a much more specific job of certification and validation. So I'm going to conclude here. I think AI has a lot of promise, but we have to recognize that no AI is an island and no AI is perfect. It has to be integrated as a semi-capable facility into processes that people are involved in. And if we're going to do this safely and effectively, then we need to develop and implement these kinds of guardrails within our system development processes, and in many cases within our legal processes in various countries. Andrew mentioned it earlier, but I do want to point to the report that was produced about a year ago. This was for the National Academy of Science in the United States on human AI testing. It's free for download. If you go to the National Academy website, nap.edu, you can download that for more detailed information about a lot of what I talked about here. So I'm going to stop sharing now and turn it over to Andrew for Q&A.
Micah, thank you so much for that wonderful presentation. You covered a lot of material, so thank you so much. People can also email me. It's Andrew Thatcher if they would like a copy of that report. I also have a copy on my desk. There's quite a lot of questions that have come in, so let's see how we do in getting through them before we run out of time. I'll go in order in which they came in. This one's from Jason Coyle. So Jason's was looking at complex emergent situations like wildfires that are threatening communities and trying to predict where the wildfires are going. And you need to try to put a plan together and probably also have secondary and tertiary plans in place. Are there potential benefits for AI in these situations?
Well, potentially. I mean, of course, for emergency situations like that, having a plan is critical. You don't want to be coming up with it, on the fly. I think the challenge that we have with an AI system is this whole biasing process. What I have found in studying the planning process is a lot of the value of planning is thinking through, well, what are possible things that could happen? What are which way could it happen? What could go wrong? Just thinking through all the contingencies and issues is really as valuable as whatever plan you come up with. So it's the understanding people get of what's happening or what could happen that's really valuable in a planning process. If a system just says, well, here you go, here's 3 courses of action, have at it, here's 3 plans, you don't go through that whole thought process. And you may not realize where the holes are and where the flaws are in those plans. And that's that biasing effect that we've seen. So the way in which I would use AI in a situation like that is as a secondary checker. So have people develop the plans and then have AI try to see if they can break it. Did you think about X? Did you think about Y? That actually is a really useful way to use AI that doesn't lead us into those kinds of problems.
Rabbit holes, I think, yeah, which is what can happen. You get quite a lot of tunnel visioning if you're using AI to make the predictions for you, as opposed to testing out predictions.
Yes.
Here's another question from Melanie. And are you aware of, Melanie writes, are you aware of anyone working on the standardization or labeling of AI in terms of testing people's awareness about when it's a person or when it's a chatbot? Are you aware of anything that's being done in that, or what should be done in that area?
There has been some work sort of looking at using a Turing test approach to AI systems. And I think some of the chat GPT is quite good enough to actually pass a Turing test, in that it talks really well. It's speech, it's text, what it does is, as a language system actually is really pretty good. And it generates, you can ask it to generate a story. It does a wonderful job of generating stories. So it can fool you into thinking it's a person. The thing it doesn't do is actually be accurate. So in that sense, if you give it tests of accuracy, then it may not do very well, but then people aren't very accurate many times either. So am I talking to a chat, or am I talking to a person who may be incorrect? You don't really know necessarily. So that's quite a challenge. I have not seen sufficient work in the labeling question, which I think is what Melanie was asking about, is how do we label this kind of output? And some people overtrust systems. We're seeing that with automated vehicles, where because there's a variety of what it's called, people expect it to be able to do much more than it does do. I think that's true of AI in general. So we have to find ways of better labeling the kind of system it's coming from, what its limitations are, and the accuracy of what it's producing.
Thanks, Micah. We've got a couple of questions which are very similarly related to one another, so I'm going to try to bunch them all together. Someone from Anonymous and some from ESSA, talking about the possible need for fact checkers. Is this a new possible set of jobs that might need to emerge from people fact checking AIs to make sure that what it's doing is correct? And I suppose it also then links to one of the points that you were talking about earlier about the control issue and where we put control, where the human and the AI control what is the outputs.
Yeah. I think if we have to have human beings be fact checkers of AI systems that are generating all kinds of stuff, that's a very poor job design. What are we doing and why are we doing that if that's what's going to require? So we're going to have better ways of doing that automatically within the systems. Now, the computer science community is doing a lot to try and solve some of these kinds of issues. I went to a wonderful presentation by some computer scientists out of Colorado a few weeks ago, who were able to go in and detect when generated images were real or fake. And also be able to go in and tell to prevent people from being able to take a photo off the web and use it to generate from. So they were embedding little microdots in there in ways that the computer program would completely screw up, trying to replicate it. And that was actually going to be very helpful for protecting artists from having their work essentially plagiarized by AI systems. So I think the computer science community is trying to address many of these kinds of issues, and that's what it's going to take in that realm.
Thanks, Micah. Here's a question from Dan Jenkins, which I'm supposing he's playing a bit of a devil's advocate here, and that is there may be a negative side to explainability and transparency, in that if we actually open up the black box, then it opens up for people gaming the system. And, so for example, a job application system, if someone can work out what the AI is doing, then they can provide the AI with the right types of answers to be able to get the best chance of making it through a selection system.
I think people do that all the time. Whether it's a human being or an AI system, you're always trying to figure out what is it looking for. The real answer, of course, is that I think the people who are using these systems have to be very clear on what it's doing and what it's looking for, and be responsible for, I think the whole liability issue is significant. Right now, people want to sell their AI system and you use it and you assume all the liability for everything that goes wrong. If I have a crash in my Tesla right now, there's no protection, even though it could have done everything completely wrong. The people who produced it don't want to assume liability. So whether it's a vehicle or whether it's a personnel selection system, the developers of that system should have liability and responsibility for the content and output it's outputting, because it does have this large influence on the process. And that's where we really have to make those systems very overt and explainable and transparent, both for people who need to protect themselves, if I'm going to buy your system, or if you're going to sell the system, or for regulators who have to regulate the system. I think it's a necessity.
Thank you. It's a tough one because it becomes a double-edged sword in some instances, but not all instances. Here's a question from Mark Maybury, is asking essentially asking your opinion on current legislation, or at least guidelines, for example, from the EU and the NIST about AI, and whether they go far enough, or whether there's still some work that needs to be done on them.
I think those are very good first starts. I don't look at anything and disagree with anything that's been put out in those documents that are coming out. The world is trying to grapple with this. Many governments are trying to grapple with it. They're worried about a lot of these kinds of issues. I think, though, that they're not specific enough. So a lot of them are general. It should be responsible. It should be ethical. It should be safe. Yes, totally agree. How do we fill in the details of that to very specific guidance that's design centered or process centered in ways that are implementable and testable, and they're able to be legislated. I can't make a law that says AI should be ethical. We can't even make a law that says people should be ethical. You have to break that down into very specific things about what you mean. And that's really what we have to do here, is we have to really specify how do we execute those things effectively. And that's where I think we have something to offer.
I think very much so. I'm quite liking the talk on ethics. Maybe that's just a personal bias. There's a couple of questions which are also related to one another, and I think refer to labeling of terms. The first one's from Dustin Sodas. I hope I've pronounced your name correctly. And that is, Dustin's talking about types of trust, especially when we talk about trust in the multifaceted nature of the different types of outcomes. You partly covered this in your presentation, but what sort of, do we need to look at different types of terms to describe trust? Because I suppose Dustin's worry is that when we just talk about trust, that we'll just get caught up in our generic understanding as opposed to our specific understanding of trust.
Yeah, I agree. I think trust can be a little broad sometimes in terms of how it's used. For instance, trust is in, do I think you're trying to cheat me, or do I think you're being, biased in some way, is different than trust of, do I think you're capable of doing something? There's a lot of nuances to the trust issue. Mistrust is different than the trust. I'm not the expert on trust, but I am concerned about this whole idea of situational trust. And I think that's really important when we look at the uses of these systems. If somebody's using an AI system in a healthcare application where it can have a negative effect on the treatment of a patient, I need to know do I trust it to diagnose or interpret a radiology report, for example? I would have the same issues if it was a radiologist reading it, but you have to know what it's capable of doing and not capable of doing. And because of those biasing effects, that is huge. So we have to find better ways of getting the utility of the system without getting into some of these potholes that we know about. And I think that comes from this, the understanding that the nuances of what its capabilities are and when it's being used in inappropriate ways.
While I'm typing an answer to one of the other questions, which I think you've answered, Peter Myrtle is asking, could you give us an example of an effective human AI teaming or successful example of a human AI teaming?
In a current real world application, not so much.
Okay.
I think you can draw some from the movies, but you can also find all the ways that those teams fall apart in the movies. So I'll leave you to the fiction side of that. But right now, these systems have not been capable enough, I think, to act as anything we would call as a teammate. Ben Schneiderman gets quite visceral when people talk about human AI teams because he thinks these systems are so they're at best tools or aids. And I think that is true of today. But I still think there is utility of thinking about, could they have more team-like behaviors? Could they be better at helping me when I need help in a proactive way of anticipating my needs, of anticipating my goals? In that sense, if we could provide them with some of the capabilities that would allow them to interact as a more effective teammate, I think there would be utility in that down the road. But I think we're a long way from there.
That's a nice answer. Here's a question. I suppose it's flipping it around. We've talked about the human side of things, and that is it possible, do you think, for an AI to understand when the human being is impaired? Or possible, but also maybe if I might add, sensible for AI to determine when a human is impaired and then to take over the task?
We have examples of that today in some aircraft jets that the Air Force has right now. They have a system that if they sense the system is approaching the terrain, it's called automatic GCAS. It'll automatically pull up and avoid the terrain. So we have examples where automation is taking over control from the human in cases where the human might be impaired. It doesn't try to predict why it's impaired. It just says, look, you're going to crash if I don't pull up. So it does that. But certainly you could look at applications where, if it had, a breathalyzer input, for example, it could tell if you were trying to drive drunk. You have sensors on it where it can tell if you've fallen asleep. I think there's a lot of research going on where that's trying to determine human state information and use that to provide input of, oh, the person's passed out or asleep, I need to take control. So that there certainly is work going on in that area. I would say every time we look at systems that do that, though, of course, there is the other risk of where people try to basically fool the system. And we see that happening a lot now. In the Tesla example, it can tell if your hands are on the wheel, supposedly, and then it will beep or stop working if you if it doesn't sense your hands there. I will say from experience that it's not very good at actually telling if your hands are on the wheel. It will often gives beeps when your hands are there. But we also see examples of people selling weights for the wheels that will fool it into thinking that the human is there when they're not. So we have a long history of seeing this with automation and alarms where people will try to fool the alarm systems. So, for every measure, there's a countermeasure, and that is the challenge.
Thanks very much. I see we're running over time and we're starting to have people dropping out now, which is to be expected. So I'm just going to take another couple of questions. Those who need to drop out, feel free to drop out. You can catch the recording and you can just go, it'll be available on IEA's YouTube channel a day or so afterwards. And you can see which questions that were answered and what Micah's answers were. Here's a question from Anna Ferreira. Thank you very much. Any particular recommendation on new HF tools and methodologies used to evaluate IA-infused applications. It would seem that some traditional HF methods and methodologies are lacking the depth which are required to deal with some of these new AI challenges.
Well, actually, I think a lot of our methods and tools are very appropriate, and we've been using them to evaluate automation and AI for many, many years in its different iterations. So it really comes down to having good testing paradigms. You have to create scenarios where you're going to be looking at not just does it perform well, but where it doesn't perform. You're going to have to look at people's ability to understand and interact with it in those kinds of situations. You have to have sensitive metrics. We have to be looking at things like workload and situation awareness and performance in edge cases. So it comes down to good scenarios, good testing, good simulation environments. In many of the kinds of application areas we're looking at, I don't think a lot of the testing has necessarily incorporated all of that in a very systematic fashion. And so that becomes, I think, really important. So I think our methods and our tools apply well, but we have to do a much more detailed job of being able to apply it in many of these kinds of situational domains. And largely that has to be done in simulation environments. I have real qualms with the current practice of throwing the technology out into the wild and letting people beta test it, essentially. Beta testing AI technology on the nation's highways is incredibly dangerous and unethical. And that's really the world we're in right now. It's the Wild West out there in terms of how these systems are being tested in real world applications.
I'm going to take one more question, I think. This is one specifically for HFE, and that is, do you know of examples either in the US or elsewhere in the world where HFE has been involved in the construction or formulation of ethics guidelines and guardrails at a national or a regional level?
Not sufficiently. It's something we're working on here and are actively trying to engage in, but it's a hard educational process, because the people who are working on those guidelines are largely, people who don't have backgrounds in engineering. They don't have backgrounds in human factors. So you have to do a lot of education as to, what the research shows, how you can do this safely and effectively. We have to be part of that conversation, I think. At least here in the US, there's a lot of attention being paid to people who are developing the systems. And of course, they have a bias of getting those systems out there into the world. And so they have a very different perspective than I think people who are coming from the safety perspective, which we are, but not just as a, no, you've got to stop everything perspective, but as a, okay, here's how we do it, but here's how we do it safely. And here's how we do it effectively. And that involves a little bit of compromise, but involves a lot of education. And so it's something we're trying to engage in.
Micah, I'm unfortunately going to have to bring the session to a close. We're 10 minutes over, and my apologies to Jason, Dan Jenkins, Dan Locke, Eric Connors, Toby, Alberto, Smar, Autumn, Mark Maybury, whose questions we haven't got to. I think we actually have answered 20 questions in the time. We still got 10 left. But I think the number of questions and the sophistication of the questions is definitely demonstrating the value of this presentation. So thank you very much for coming through, and thank you very much to all our attendees who made the time to be here. We really appreciate your time. If you've got suggestions for topics that you would like the IEA, and particularly the Future of Work task force to look at, please feel free to email me and let me know. This presentation and the answers to the question will be available, as I've said, on the IEA YouTube channel. You can find a link to that just by going onto YouTube and typing in International Ergonomics Association, and you should be able to find that. Otherwise, there's also a link from our webpage. And as a last message, Micah, thank you very much for your time and your work in this area and many other areas in HFE. It's very much appreciated. Thank you very much.
Thank you so much, Andrew, and thank you to the audience.